technically you can solve this question by using an exponential equation, but I think it's simple enough that most of you are just going to do some percents here. So let's keep it in that category. Thomas installed a new stove in his restaurant. At the time of installation, the stove had a value of $800. Thomas estimates that each year the value of the stove will depreciate by 20% of the previous year's estimated value. What is the estimated value of the stove exactly 2 years after Thomas installed it? So if you don't know what depreciate means, that's not a common English word, you hopefully can just use the answer choices to help you. Look at all these choices. No matter what happens, the price is going down. Right, so depreciate just means decrease, but it's kind of like an exponential decay situation. It's decreasing by a percentage, and so you might. This is not a question that is from the student question bank. It's only in the educator question bank of College Board. My thinking there is that this is an old SAT question that they're repurposing, not one that you might see on the current test. But my only reason that you wouldn't see it on the current test is I wonder if they would use the word depreciate. I got to go back and check. That might appear somewhere in some SAT question on a practice test, but I can't remember any. That feels like a word that they try to avoid nowadays, but you should know it just in case. But otherwise, all the skills here are the same. So let's go through this. Because I know it's a decrease by a percentage, I know I'm going to use the open formula with the 1 plus or minus p. And let's just do it in 2 steps. I'll show you how to do it in one later, but let's just do it in 2 steps, right? So the first year, it's going to depreciate by 20%, right? So this is year 1. And so you're going to do 800, and depreciating by 20% is the same as kind of just getting 80% of it. So regular calculator here, 800 times 0.8 is 640, right? So this is now a trap because some of you just aren't going to read that it's 2 years. So we just got to do it again. And now, because it says it's 20% of the previous year's estimated value, we're decreasing by a different number each year. It is the same percentage, but that's the difference between a linear change and an exponential change, right? So this is going to be, I see I already messed it up. This is going to be 640. So 640 is our new original value, right? Because it was our new value before. Now it's our new original for the next year. The percent is still the same. And now we're going to get a new value, right? So same thing, we're going to do 640 times 0.80. So times 0.8 is 512. And there you go. That's after 2 years. So we're done. That's the answer. So I think, we could do this exponentially, but I think many of you are just going to see it as a percentage and just kind of do it twice. But you got to make sure you do it twice. Obviously, they know some of you are going to stop short because you just kind of do it once and they're like, oh, answer done, x equals, you have the kind of like, that kind of manic energy about math where as soon as you see an x equals, you're done. But luckily, the exponential equation that we would use is barely different than the percentage equation. So this is an open formula for percent change. That's what we're using here. If you need to turn it into an exponential, just throw a little t on top of the percentage part because that now accounts for the fact that you're taking the percent multiple times. So our original is still 800. We're still depreciating by 20%. We can throw 2 in for t. T stands for time, basically. Like how many cycles are we going through? So there's 2, and that gives us our new value. So it's 800, I don't know why I'm smushed in there, times 0.80 squared. So now just order of operations, right? So you're going to do 0.8 squared first. That's 6.64. And now 800 times 0.64 gets us exactly the same answer that we had before, right? 512. So that works. And you should know how to do that because a lot of questions in the SAT will involve an exponential. And if that exponent is high enough, it starts to be much more efficient to just use the exponential equation than to take a percentage 3, 4, 5, 6 times, right? Like it gets to be tedious otherwise. So the exponent is just condensing things. So yeah, watch my lesson on exponential equations if you need kind of more advice about how this works. But the reason it does work is that the open formula that we need for just single percentages is exactly what we would use for exponentials, where we're taking percentages multiple times. It's just the same formula with a little exponent on it. So it's really convenient for us. That is why I invented the open formulas. That is why I am such a big fan of them. It's all connected. It makes it so we have to memorize less for the SAT, which anything we can do to shorten that list of memorization things is good for us. It's a lot.